Hello and welcome to my channel Cosmic Connection. In this video we are gonna talk about on neutron stars. Neutron stars are some of the most fascinating objects in the universe. They are incredibly dense, ultra-compact objects that are formed when a massive star collapses at the end of its life. In this video, we will explore the properties of neutron stars, how they are formed, and some of the mysteries that surround these incredible objects. 1. Formation of neutron stars. Neutron stars are formed when a massive star collapses at the end of its life. As a star ages, it runs out of fuel and can no longer generate the heat and pressure needed to support its own weight. As a result, the star begins to contract and its core collapses. If the mass of the core is between 1.4 and 3 times that of the Sun, the collapse will be stopped by the strong nuclear forces that hold the protons and neutrons in the core together. The resulting object is a neutron star, which is composed almost entirely of neutrons, subatomic particles with no electric charge. The process of forming a neutron star is extremely violent and releases a tremendous amount of energy. This energy can cause the star to emit a burst of electromagnetic radiation, such as a supernova explosion. Neutron stars are incredibly dense, with a mass that is typically around 1.4 times that of the Sun, but a size that is only around 20 kilometers in diameter. This makes them one of the densest objects in the known universe. They have incredibly strong gravitational fields and extremely high surface temperatures, and they can spin at incredibly high speeds. Neutron stars are some of the most fascinating objects in the universe, and their properties are still being studied and understood by scientists today. 2. Neutron star size and density. Neutron stars are incredibly small and dense objects. They have a typical mass of around 1.4 times that of the Sun, but a size that is only around 20 kilometers in diameter. This makes them one of the densest objects in the known universe. To give you an idea of just how dense neutron stars are, consider this. If a neutron star were the size of a sugar cube, it would have a mass of around 1 billion tons, the same as a mountain. They are so dense that a sugar cube-sized piece of a neutron star would have a mass of around 1 billion tons. The density of a neutron star is so high that the protons and neutrons in its core are squeezed together until they form a solid ball of nuclear matter. This ball of matter is known as a neutron star crust. The outer layers of the neutron star are composed of neutrons, while the inner layers are composed of protons, neutrons, and electrons. Despite their small size, neutron stars have extremely strong gravitational fields, which cause their surface to be highly curved. As a result, the surface of a neutron star can be described as a mountain, with a height of around 100 meters. 3. Neutron star surface. The surface of a neutron star is a fascinating and complex place. Neutron stars have extremely strong gravitational fields, which cause their surface to be highly curved. As a result, the surface of a neutron star can be described as a mountain, with a height of around 100 meters. The surface of a neutron star is also incredibly hot, with temperatures reaching up to 1,000,000 degrees Celsius. This high temperature is caused by the intense heat generated during the formation of the neutron star, which is released over time as the star cools. The surface of a neutron star is also subjected to intense magnetic fields, which can be up to 1 billion times stronger than that of the Earth. These magnetic fields are thought to play a key role in the emission of electromagnetic radiation from neutron stars. In addition to these extreme conditions, the surface of a neutron star is also subjected to tremendous pressures, with the weight of the star's outer layers bearing down on the surface. Despite these challenges, the surface of a neutron star is surprisingly stable, thanks to the strong forces that hold the particles in the star together. It is a fascinating and complex place that continues to be the subject of much study and research. 4. Magnetic fields of neutron stars. Neutron stars have extremely strong magnetic fields, which can be up to 1 billion times stronger than that of the Earth. These magnetic fields are thought to play a key role in the emission of electromagnetic radiation from neutron stars. The origin of the magnetic fields of neutron stars is not fully understood, but it is thought that they may be remnants of the magnetic fields of the original star that formed the neutron star. Alternatively, the magnetic fields of neutron stars may be generated by currents of charged particles flowing within the star. The strong magnetic fields of neutron stars can have a number of effects on the star and its surroundings. For example, they can cause the emission of electromagnetic radiation, such as radio waves and X-rays. This radiation is thought to be produced by particles accelerated by the magnetic fields and can be detected by telescopes on Earth. The magnetic fields of neutron stars can also affect the star's spin and shape. For example, if the magnetic field of a neutron star is not aligned with its rotational axis, it can cause the star to wobble or precess. This precession can be detected by astronomers and used to study the internal structure of the star. 5. Neutron star mergers. When two neutron stars collide, they can create a highly energetic event called a neutron star merger. These mergers are thought to be the source of short gamma-ray bursts and can also produce elements heavier than iron through a process called rapid neutron capture. During the neutron star merger, the two stars spiral towards each other, eventually merging into a single object. The merger releases a tremendous amount of energy, which can be detected by telescopes on Earth as a burst of electromagnetic radiation, such as a gamma-ray burst. In addition to producing electromagnetic radiation, neutron star mergers can also produce elements heavier than iron through a process called rapid neutron capture. This process occurs when the dense matter of the neutron stars is subjected to extreme pressures and temperatures during the merger. Under these conditions, the protons and neutrons in the matter can fuse together to form heavier elements, such as gold and platinum. 6. Neutron star classification. Neutron stars can be classified based on their properties, such as their mass, radius, surface temperature, and spin rate. One way that neutron stars are classified is by their mass. Neutron stars can have a mass of between 1.4 and 3 times that of the Sun, and those with a mass of around 1.4 times that of the Sun are called canonical neutron stars. Those with a mass greater than 1.4 times that of the Sun are called massive neutron stars, and those with a mass less than 1.4 times that of the Sun are called low-mass neutron stars. Another way that neutron stars are classified is by their radius. Neutron stars can have a radius of around 10 kilometers to 20 kilometers, and those with a radius at the lower end of this range are called compact neutron stars. Those with a radius at the higher end of this range are called extended neutron stars. Neutron stars can also be classified based on their surface temperature. Those with a surface temperature of around 1,000,000 degrees Celsius are called hot neutron stars, while those with a surface temperature of around 100,000 degrees Celsius are called cool neutron stars. Finally, neutron stars can be classified based on their spin rate. Those with a spin rate of around a few hundred times per second are called slow neutron stars, while those with a spin rate of around 1,000 times per second are called fast neutron stars. 7. Neutron star mysteries. There are still many mysteries surrounding neutron stars, including the nature of their internal structure and the mechanism by which they emit electromagnetic radiation. These mysteries are the subject of ongoing research in astrophysics. One mystery surrounding neutron stars is the nature of their internal structure. Neutron stars are incredibly dense objects, and the conditions inside them are extreme, with temperatures reaching up to 1,000,000 degrees Celsius and pressures that are much higher than those found anywhere else in the universe. Despite these extreme conditions, the matter in the interior of neutron stars remains stable, thanks to the strong forces that hold the particles in the star together. However, the nature of these forces and the structure of the matter in the interior of neutron stars is still not fully understood. Another mystery surrounding neutron stars is the mechanism by which they emit electromagnetic radiation. Neutron stars are known to emit a wide range of electromagnetic radiation, including radio waves, X-rays, and gamma rays. The mechanism by which this radiation is produced is not fully understood, and is the subject of ongoing research. Overall, there are many mysteries surrounding neutron stars, and their properties and behavior continue to be the subject of much study and research in astrophysics. 8. Neutron star observations. Neutron stars can be observed using a variety of telescopes and instruments, including radio telescopes, X-ray telescopes, and gravitational wave detectors. Radio telescopes can be used to detect radio waves emitted by neutron stars. These radio waves can be produced by charged particles accelerated by the star's magnetic fields, and can provide information about the star's magnetic field strength and geometry. X-ray telescopes can be used to detect X-rays emitted by neutron stars. These X-rays can be produced by the hot plasma in the star's magnetosphere, and can provide information about the temperature and density of the plasma. Gravitational wave detectors can be used to detect the gravitational waves emitted by neutron stars. Gravitational waves are ripples in the fabric of spacetime, and can be produced by the movement of massive objects, such as neutron stars. Detecting these gravitational waves can provide information about the movement and properties of the neutron star. I hope you enjoyed learning about neutron stars in this video. These ultra-dense objects are truly amazing, and their properties are still being studied and understood by scientists today. From their strong magnetic fields to their role in the production of heavy elements, neutron stars are truly one of the most interesting objects in the universe. Thank you for watching.